Yeah. So, good evening, everyone. In the yesterday's session, we started, we started a new batch on data structures and algorithms with Java. Okay. So, the title of the course is Data Structures and Algorithms with Java. Prerequisite for this course is CoreJava. Compulsory. You should have minimum knowledge in CoreJava, like how to write a loop, how you can able to write if conditions, so how to write methods. Okay, next and after that, constructors, overloaded methods, exceptions. These things you must have some idea. Coming to the timings, this is very very important point, friends. The timings of this session is not at 7 o'clock. The timings of the session is from 6 p.m. to 7:15 every day, from 6 o'clock to evening 6 o'clock to 7 or 7:15. The session will be there on weekdays. Sometimes weekends also we are going to take the sessions. Then demos. Yesterday we started one new demo. Okay, so today also demo will be there. Even tomorrow, if possible, on Sunday also we will plan for a demo, and from Monday onwards we will have our regular classes. Okay, one sec. From Monday onwards, we are going to have our regular classes. Already, some 5 to 6 students already paid the fee. I request remaining students also, okay, to clear the fees. Okay, the duration of this course is exactly 2 months. So, running notes, images you are going to get, videos for 6 months access you are going to get. Next and after that, live classes will be there. Maximum try to attend live classes. If time is not permittable for you, then only go for recorded videos. Maximum try to attend live classes. There are some topics are there which we need to attend only on live classes, that I will give prior intimation. And coming to the syllabus, yesterday I explained very clearly what is the syllabus that we are going to discuss. And I started one chapter. What is that chapter? Recursion. I have given a clear introduction. Boss, why we need to go for recursion? If any, why we need to go for method? If any task is repeatedly required, if any task is repeatedly required, then we can go for methods, because reusable concept. I explained how to use that method. Then whenever we have a method, sir, internally Java virtual machine is going to create one stack to maintain that method calls. So from one method to another method, how redirection is going to be happen, that part we have seen very clearly with example. Sir, after that, even we had multiple discussions how that stack is going to maintained. I explained very clearly. And we covered one example where a method can call the same method, sir. Yes, if you take this example, here there is a method called m, which is printing some message called good evening. Once if the message got printed, again we are going to call the same method again. Is it possible or not possible? Yes, it is possible. Sir, how it is going to execute, I explained very clearly with the example. But the problem with this approach is, a stack is created, a method is going to be called, means corresponding entry is going to be stored inside stack. So after executing that method, again that m method is calling m method, again m is calling m, again m is calling m. Like that, if m is repeatedly called, then what will happen? There is no boundaries, right? It is keep on calling. At a certain point, our stack is going to be full. So if stack is full, what will happen? Stack overflow error. Okay, if stack is full, we are going to get a stack overflow error. Whenever we are getting stack overflow error, the program termination is always abnormal, because it is a runtime. We don't know how much stack space is allocated by Java virtual machine. So how to stop this? For that, we have a scenario. I think up to this, I explained in the last sessions. So the people who attended today, so somewhat confusion. Don't worry, you can recall this later. Sir, up to this, any doubt? Please confirm. Up to this, everyone clear? Please confirm.
Yes.
Sir, please respond. Response is very, very important in these classes. Interaction is highly recommended. If everyone clear, then I can start. Next one. Sir, clear? Right. Sir, next point here is, listen carefully. I'm going to talk about some important, important points about recursion or about method calls. I want to talk about some important points related to these method calls. What are those points? Sir, first point, a method can called by another method or some other method. Yes, a method can called by some other method. Sir, a method can be called by itself. Yes, a method can be called by itself. There is no problem at all. A method which is called by itself is called as recursion. A method which is called by itself is called as what? Recursion. If you call a method by itself, that is called as what? Recursion. And the process, okay, the process is called as recursive process. Recursive process. And so the method which is invoked, in this process is called as recursive method. So that process is called as what? Recursive method. Sir, very, very important. Sir, the main hero, okay, the main hero in recursion is, can you please tell me with the knowledge whatever I have given? So who is the main hero in the recursion? Can you please confirm? Yes,
Recursive
please.
method.
Who is the main hero? Any other?
Methods.
Methods. Still any other?
The stack.
Very good. Stack
Method.
is the hero. Why? Because stack is the main place. Which method, how many times, okay, the movement of the direction, everything is going to be decided by which method, which thing? Stack. Stack is going to give control. Okay, sir. Clear, sir? Sir, clear?
Yes.
Then, sir, yesterday we have taken one example, okay, like a test.java program. If you remembered, this is nothing but what we covered in the last class. Just main method is there. Main method is calling some method. That method definition is having two instructions, two lines. What is the first line? It is printing a message called good evening on the screen. At the same time, we are calling this method again. So internally, what will happen? A stack is going to be created here. Sir, first Java virtual machine is going to give direction for the main. Array main, can you please start your execution? Main is not having any instruction. Sir, main is invoking the method m. So what this method m is going to do? Boss, it will execute all the instructions what we have in this. Again, it is calling the same method. So it will call em method. Again, it will print. Again, it is going to call em. Sir, is it a ending process? No, it is a never ending process. Whatever stack that they have given, it is going to be filled. So stack overflow problem we are going to get here. Okay, stack overflow error problem we are going to get here. If you observe, yesterday we executed this code and I showed the output also. Have a look once. Test.java I'm taking. The code is going to compile fine. If you run the program also, sir, the output is good evening message is continuously printing. At a certain point, it is a stop. At a certain point, it is stopped. If you see what is that message? Stack overflow error. Okay, this one is called as what, sir? Recursion. Sir, there are two types, two types of two types of recursion, two types of recursion based on number of entries in stack. Sir, how many entries will be there? One is nothing but finite recursion. One is nothing but finite recursion. Second one is infinite recursion. First, I'm going to talk about infinite recursion. Infinite recursion means what? It never terminates. So I can say this is nothing but a best example for this. And even just I'm copy pasting the output up to certain code point of view. Sir, this is called as what? Infinite recursion. If you are clear with infinite recursion, what is mean by finite recursion? How you can write code for finite recursion? I will demonstrate. Any doubt up to this? Sir, clear everyone? Please confirm.
Yes.
Then, sir, what is finite recursion? It should stop at a certain point, sir. It should stop at a certain point. Sir, I am going to give array boss. I want to print this good evening message only 3 times. Here, I am going to give the input like 3, m of 3. Sir, what is the meaning of this m of 3? My method m is going to execute how many times? Only 3 times. Then, if a method is receiving some value, it is called as a parameter or argument. In the method definition also, we have to take that. Sir, it will print good evening. Sir, I am explaining. First time, we are going to call main method. Main method is calling m of 3. What will happen? It is printing a message called good evening, and it is going to call the same method. Sir, it is also expecting the parameter, right? What I will do is I will reduce this n value by 1 unit. So I will pass n minus 1. Then what will happen? It is going to call m of 2. Again, it will print good evening message. Sir, again it is going to call m of 1. Sir, again it is going to print good evening. Sir, after that what will happen? Sir, again it is going to call for m of 0. Sir, if you see in the output, we got our requirement. 3 times got printed. I have to stop. How to stop, sir? Very simple. I am going to take, if n is equal to 0, boss, return. Come out from the method. Come out from the method. Then what will happen? It won't print anything. It will come out. So I told in the yesterday, corresponding entries from the stack are going to be deleted and it will return back. It will delete and it will return back. It will delete and it will return back. It will delete and it will return back. That's all, sir. Sir, that's all. What is the output that we got? Total 3 lines got printed. Sir, let me check really is it going to work or not. So I'm going to compile the code and I'm going to run. You can see, sir, we got that message, good evening. How many times? 3 times. That depends. You can pass any number of times. It is going to execute up to that particular value, whatever you have given. This process is called as what? Finite recursion. A method which is called by itself and terminates. Let me write the definition. A method which is called by itself and terminates at a certain point. It is going to terminate at a certain point. Such a type of methods are called as what? Such a type of recursion is called as what? Finite recursion. Sir, everyone clear with this approach? Please confirm.
Yes.
Sir, need response from everyone. Clear? Right. There is one more theory topic I need to cover. What is that? Is base condition. What is base condition? Sir, very simple. Only 2 people are responding in the class. I don't know remaining people. Sir, what about base condition? To terminate or to stop flow of execution, or to break, okay, to break the method call, to break the method call. So to terminate or to terminate or to stop flow of execution or to break the method call, we have to, okay, we have to write some special condition. We have to write some special condition, which is called as, base condition, which is called as base condition. Sir, it is used in which recursion? Finite recursion. Already I covered. Okay. Sir, once if the base condition, is satisfied, okay, then recursion will stop. Recursion will stop automatically. Automatically, recursion is going to be stopped. And we have to write, base condition very, very clearly. Okay, by identifying all possible inputs. Okay, by seeing all possible inputs, you have to write. Best example, sir, I am going to take this program. See, if I am giving m of 3, what happened? Sir, it is executing 3 times. Perfectly, it is working. But by mistake, if you are giving -3, even though there is base condition, it never stops. Observe carefully. So it is not a proper base case. It is not satisfying. What we have to do, instead of equal to 0, less than or equal to 0, you have to take. So if the number is 0 or negative value, it will stop. Have you observed? Since it is a negative value, nothing is there to print. Like that, it is going to write. Such a type of conditions is called as what? Base conditions. Sir, I think, friends, everyone got very clear clarity about this base condition. Sir, please confirm finite recursion, infinite recursion. So what is mean by base condition? Up to this, do you have any doubt?
No, sir, but can you just scroll up so that we can write the code notes, please?
No need. I will share this code. I will share these notes. Don't worry.
Okay.
Sir, clear everyone, please confirm. Right. So there are still some 2 to 3 definitions are there. Let me cover those definitions also. You will get clarity on that. One is direct recursion. Okay, direct recursion. Sir, what is mean by direct recursion? Sir, it is a special case in recursion. It is a special case in recursion where a method calls, okay, some method which in turn calls same method. Sir, I am going to call a method. Okay, I'm going to call a method. That method is going to call the same method. I don't want to take any example, just a sample code I will take. I have a method m. Inside this method, sir, we have some instructions are there, maybe 2 lines or 3 lines, like that. Again, I am calling m. Sir, it is called as what? Direct, direct recursion. Sir, why it is direct? Because we have only one method is there. In that 3 lines are there. After executing the 3 lines, again we are going to call the same method. This type of recursion is called as what? Direct recursion. Sir, everyone clear with this terminology? Please confirm. Sir, everyone clear with this term? Please confirm. Clear, sir?
Yes, sir.
Right. Yeah, just a second. Yeah, sir, please confirm everyone clear up to this, whatever I covered, please confirm. Can I go for next one?
Yes, sir. Yes, sir.
Right. So what is the next one here is indirect. Indirect recursion is there. Indirect recursion is there. So what is mean by indirect recursion? Sir, first I will take example. Later I will explain the diagram. I mean definition. Sir, indirect recursion means I have a method. What is that method? Is M1. In this method, I have only one line is there, sir. After that, I am calling another method M2. Sir, we have M2 method is also there, which is having only one line to execute. After that, sir, again I am calling M1. Have you observed how the scenario? M1 is invoking, which is calling M2. M2 is again calling M1. M1 is calling M2. Like that, it is a never-ending process. This type of recursion is called as what? Indirect. Sir, what is the meaning of this? It is a special case. It is a special case in recursion where a method, okay, a method calls some method, okay, which in turn calls another method, which in turns call another method. So that method, okay, redirects to previously called method. Like that we have. I hope you understood my terminology also. I don't want to take any example. Sir, you got the point, right? Please confirm. Everyone clear with the
Got it, sir.
terminology? Got it?
Yes, sir.
Right. What is the next one here is need for a recursion. Sir, why we need to go for recursion? Can you please tell me an example? Why? What is a necessary? Because already we have loops and all. Why we need to go for recursion? There are some theory points. Okay. Sir, we can reduce length of the code. Sir, even if you take a big problem also. Okay, even if you take a big problem also, maximum 2 to 3 lines of code will be there. If you take any big problem also, how many lines of code will be there? Maximum 2 to 3 lines of code will be there. That is nothing but the biggest advantage what we have. Okay, that is the biggest advantage what we have. Next term, sir, if we have any common property, then we have to go for recursion. Sir, I want to perform addition of some natural numbers. Like I have 1 plus 2 plus, so 3 plus 4 plus 5 plus, like that we have up to n. Can I use recursion? Yes. Sir, how? Because, sir, if you take these two things, sir, this is A value, this is B value. If you add, you will get a result. Can I say this one is A value and this one is B value? Again, we can do. Have you observed such a type of scenario is called as what? A common property. If anywhere common property is there, then happily you can go for what? Recursion. Sir, I want to take some best examples for recursion. What are the best examples for recursion is, sir, we have Fibonacci sequence is there. Okay, Fibonacci sequence is there. Compulsory, we have to solve this problem only by using Fibonacci, by using recursion. Sir, even we have towers of Hanai. Towers of Hanai problem is there. This one also we have to solve by using recursion. So divide and conquer methods are there. So this one also we have to solve by using recursion. Even we have subsets are there. Subsets are there. This one also we have to solve by using recursion. Subsets. Okay, next, sir, tree traversals, BFS, DFS, n number of things are there. All these things we can solve only by using recursion. These are nothing but what kind of problems needed recursion. Sir, everyone clear with the terminology? Please confirm. Clear everyone? Please confirm.
Yeah, yes, sir. Clear.
Right. Next, what are the properties? What are the properties of recursion? Sir, what properties we have to maintain in the recursion? We know all the properties well. Okay, the properties are nothing but first one, performing. So performing same operation multiple times with different inputs. Sir, I want to perform same operation multiple times with different inputs. Just now I told, right, same scenario. And in every step, we will divide the problem into simple. In every step, we are going to divide the problem statement into simple. And at last, base condition to stop or to terminate recursion. That's all, sir. This is nothing but what is mean by recursion, what we have. And let me write steps to implement. Steps to implement recursion. If I have any problem statement, how we can able to implement that means we have some basic steps are there. In the first step, we have to define base case. We have to define base condition, which is very, very important. Second one, we have to define recursion case also. One is base condition, one is a recursion case. Recursion case is going to execute continuously. Base condition is nothing but what? To stop that infinite execution, we have to use that. Okay, there are two scenarios are there. One is base condition, another one is recursive code. Next one, we have to write a logic to terminate. Sir, if I am writing any recursion and if I am writing any base condition, it is not sufficient. While writing the recursion case, you have to make sure that at certain point, the base condition should be satisfied. Once if you practice more problems, we will get. Then last one, we have to combine the solution. At last, we have to combine the solution. Sir, it is going to be helped by stack data structure. Sir, if you are clear with these 3 points, whatever I covered, I am going to start programs now one by one. Sir, where all the logics around 20 applications I am going to explain, you people are going to get complete clarity. Sir, any doubt? Can I start the cinema? Please confirm everyone.
Yes, sir.
Can I start? Please confirm, friends. Sir, why only one person is responding? Remaining people. Yeah, cool. Now, sir, very, very important definition and program I am talking now. Sir, now I will take one program, sir. Then I will explain the case. What is that? I'm going to take one program, example program. Very, very important. Please listen. See, I have a method is there. This method has to execute 5 times. Inside this method, what I am doing is I am trying to print that number system.out.println of I am taking n. After that, I am calling the method by passing n minus 1. Can I say this is nothing but recursive code? This is nothing but recursive code. Sir, what it is doing every time it is trying to reduce the value of n by 1 unit so that at a certain point, it is going to satisfy 0. In such a cases, simply I am going to terminate. If I execute this program also, the output what we are going to get is nothing but 5 to 1. Like this we are getting. But in which order it is going to come, I will show you. 5 to 1 it is coming. How it is going to be displayed, I am going to take with the help of stack. Listen, sir, it is going to maintain a stack first initially. JVM is going to invoke main method, okay, and main method is going to call another method by passing 5, sir. Okay, so this method, what it is doing, it will check is 5 is less than 0. No, it will print 5 on the output. So after that, what will happen? It is calling m by passing n minus 1. 5 minus 1, 4. Sir, it is internally calling what? M of 4, sir. Then what will happen? it is going to call one more time. Since 4 is not less than or equal to 0, it will print 4. Again, it is going to call for 4 minus 1, which is nothing but 3. Then it will print 3. Again, it is going to call for m of 3 minus 1, which is nothing but 2. Sir, it will print 2. Again, it is going to call for m of 1. So what will happen? It will print 1. And again, it is going to call for m of 0. Observe carefully. Whenever 0 is coming, it is not printing anything. Simply we are terminating. So that what will happen? Sir, reverse order. Have a look once. M of 0 terminated and control will come here. M of 1 terminated, control will come. So M of 2 terminated, M of 3 terminated, M of 4 terminated, M of 5 terminated. It will give acknowledgement to the main, saying that the program execution completed. The output what we got is 5, 4, 3, 2, 1. Is it correct? Yes. Sir, how internally this recursion is working? If you are clear with this stack diagram, I will demonstrate some tree diagram also for this. Everyone clear with this, friends? Please confirm.
Yes.
Everyone clear?
Yes, sir.
Right. Now, sir, what is the tree diagram for this? I think this is more easy to understand. Please listen. First, we called m of 5. This m of 5 method is having these two instructions. What is the first one? Sir, it is printing 5. After that, it is calling m by passing 5 minus 1, which is nothing but 4. Again, m of 4 is having two instructions. One is it will print 4 and it will call m of 4 minus 1, 3. Sir, again, it is having two instructions. Print m and it is going to call for m of 2. And it is having two more instructions. Print 2 and it will call for m of 1. Sir, print 1, it will call for m of 0. Whenever 0 is coming, it will stop. It will stop. Now, what is output? The order is 5. After that 4. After that 3. After that 2. After that 1. This is very, very important diagram. This tree diagram is very, very important. Why? Because if you understand how this tree diagram is going to come, if you have a diagram, you can write code. If you have a code, you can derive the diagram. If anyone is there, easy to write recursive programs. In future, you are going to get clarity. In these 2 days, tomorrow and the day after tomorrow, I am going to take multiple applications. You people are going to get full-fledged clarity how this tree diagram is going to be helpful while writing the recursive code. This is one side for coin, sir. There is another side is there. That example I am going to take now. Sir, up to this, any doubt?
No.
Everyone clear with the terminology?
Yes, okay.
If you
Clear.
are clear with the terminology, I have one small doubt. You have to clarify that doubt. Sir, clear up to this? Please confirm everyone. Sir, in this total program, how many lines of code is there? I think line number is also visible for you. Tell me how many lines of code is there? How many lines of code is there?
14.
Array. 14 lines of code is there. In all these lines, which line is a recursion? Can you please tell me?
Right.
Yeah, 8 line.
8th line is recursive. Am I right?
Hmm.
Now, after 8th line, is there any line in the method?
No.
No. Then there is a name for this type of recursion. This recursion is called as tail recursion. Sir, what is mean by tail recursion? So tail recursion is nothing but just I am taking an example. Tail recursion. What is mean by tail recursion? Very simple, sir. Inside recursive method, after recursive call, if we are not taking any statements, so then such type of recursion is called as tail recursion. If you take this example, after this 8th line there is no lines, that's why this one is called as what? Tail recursion. I think without giving the definition, I covered the total example, friends. So once if you see the next non-tail recursion, you will get more clarity. Up to this, do you have any doubt?
No.
Everyone clear? Clear means I will go for the next step. Everyone clear?
Clear, sir.
Right. Sir, what about next one? The next definition, I think you know. What is the next definition? Non-tail recursion. What is mean by non-tail recursion? Inside recursive method, after recursion call, if we are taking any statements, then such a type of recursion is called as what? Non-tail recursion. Example, sir, this line I want to take after recursion call. After recursion call. Sir, what will happen? This is called as a non-tail. Why? Because after the method call recursion is there. What is advantage? Sir, no advantage. Just we have a small scenario. What is that scenario is? First, we are calling a method by passing 5. So it is having two instructions. Sir, first instruction is not printing. First instruction is method call. For which one? 5 minus 1, 4. Then what will happen? Sir, for these two method calls, m of 3, because it is a method call, first it will execute m of 2. Then one more instruction. Then for m of 2, it is going to take m of 1. Sir, one more instruction is pending. Then, so whenever 1 is coming, then it is going to call m of 0. And one more value is pending. Sir, whenever m of 0 is coming, it is going to terminate. It will terminate. Sir, up to this clear, right?
Yeah,
Please
exactly.
confirm. Now, this statement never executed, right?
So this will print in ascending order, right?
Yes, now this statement will get a chance. Whenever 0 value is coming, since it is returning, after that, one more statement is pending. Sir, for which method call these two lines are executing? 1, right? So 1 will print here, 2 will print here, 3 will print here, 4 will print here, 5 will print here. So what is the output that we are going to get is, sir, 1, 2, 3, 4, 5. This is the output. If you want, let me cross check. Clear, friends, everyone? This type of recursion is called as what? Non-tail recursion. If you understand these two styles of recursion, remaining programs will become very easy for us. Any doubt up to this, everyone?
Sir, one basic doubt, sir, if you do not mind.
Yeah, please, you can ask.
Sir, in the line number 6, instead of written, can we have the break or anything?
No, sir. We have only two options are there. One is we can use break or we can use return. Break means break is applicable only for if conditions loops.
For
If
loops.
for loops, if you want to use break, compulsory inside loops only we have to take.
Okay, sir. Okay.
Got it?
Okay, sir.
Hmm. Yes. Any other questions?
Can we use continue instead of return?
No. Continue, break are applicable only for loops. Okay.
Okay, sir.
And one more important points, friend. If you understood these two programs, how 1 to 5 is printing, how 5 to 1 is printing, 99% recursion problems we can solve. majority top level problems are there. All those problems we can. Sir, best examples I am going to tell. If I want to reverse any number, if I want to reverse any string, wherever reverse concept is there, you can take reversing of stack or queue or anything. Wherever reverse situation is coming, blindly we can use this recursion. Am I right? Correct, friends? If they have given a string, assume that they have given a string. What is the string they have given is ABC. They asked you to reverse this. I will take a stack. I mean, I will take a recursion where I will push A. So I will push B. I will push C. Method calls. Now, if you pop C, B, A, is it reverse or not? Yes.
Yes.
The technique which we have to use for this is previous example. And in this example, if you take ABC, what output we will get? ABC only. So we have two options. For reverse, one code. For non-reverse, we have to use one code. So if you understand these two stages, programs are very simple. Clear, everyone?
Yes.
Actually, this is not clear to me. How it's printing 1, 2, 3, 4, 5.
Madam?
How it's printing 1, 2, 3, 4, 5.
Hmm.
It should print like 5, 4, 3, 2, 1, right?
No, no. I'm telling if you replace the statements, the order is going to different. See here, first method call is giving priority. From M of 5 to M of 4 will come. Even though it is having some work, urgent call we made. That's why it will go here.
Okay.
Again, it will go here. Again, it will go here. Again, it will go here. After completing this particular task, oh, we have some other task. Let me finish that. Are you understanding? Priority wise, it is going. See, there are two situations. I'm going to start class at 7 o'clock. You have a immediate work is there. You need to eat biryani. So, are you going to complete the class and you will eat biryani, or first you will eat biryani and taking the class? Two options are there, right? Just that order which I am taking. First complete the class, then take the biryani. For completing that class, it will take 1 hour. You need to wait. After completion only, you have to open that. Second case is what? You can open and you can eat. After that, you can join the class. Two options. The order will change, right? Slowly you will get, madam. Don't worry. If you take multiple examples, definitely you can understand. Everyone clear with this? Please confirm, friends.
Yes, yes, clear, sir.
Right. That's all. This is nothing but what we have. Sir, up to this, whatever I covered, let me write, then I will start applications. Sir, the first topic which we have covered in this recursion are recursive algorithms. In this recursive algorithms, the first topic which we covered is nothing but introduction to methods and need for methods. Why we need to go for methods? What is the advantage that we have seen? Next, and after that, method calls, how the methods calls is going to be happened. Then inside that method calls, we are using stack data structure in method calls. Whenever we are making a method calls, what is the internal data structure, how it is going to be created. Sir, after that, if you remembered, we covered, sir, what is mean by infinite recursion? What is mean by infinite recursion? After that, we discussed about finite recursion, and writing a proper base condition. How to write a proper base condition for this recursion also we covered very clearly. So next and after that, we have seen direct recursion. Direct recursion means what? Then indirect recursion means what? So when we can go for direct recursion, when we can go for indirect recursion also, we covered very clearly. Okay, so after this, we had a discussion about need for recursion. Need for recursion. Sir, why we need to go for recursion? Next and after that, properties of recursion. Sir, when we can use, what are the properties that we have, and steps to implement. Steps to implement recursion also I covered very clearly in the last examples. Next and after that, tail recursion. Tail recursion means what? And non-tail recursion. Non-tail recursion means what? I taken one example and clearly I explained. That's all, sir. Then we are going to talk about, second. So tail recursion and non-tail recursion. Sir, here we are going to talk about applications, applications of recursion, applications of recursion. Sir, I'm going to cover around 20 applications on recursion. Sir, one is nothing but sum of natural numbers, sum of natural numbers. Second one is factorial of the given number. So how you can able to calculate by using recursion. Next and after that, multiplication of two integer values by using recursion, how we can do. Next and after that, Fibonacci sequence. Fibonacci sequence, how to generate Fibonacci sequence. Next and after that, I am going to explain even Fibonacci sequence also. Okay. Anyway, these things I am going to demonstrate in the tomorrow's session. Like that, sir, total how many applications are there? 20 applications are there. Tomorrow I will explain these 5 to 6 applications. In the next 2 days, I am going to demonstrate remaining things, sir. But trust me, this Sunday, we are going to wind up these recursion algorithms. Then from Monday onwards, we are going to start a fresh topic. Maximum, I will start from the beginning because I told already. So 6 o'clock students are waiting for us. I will start these 3 chapters in the coming week. Okay, right. If you are having any queries, please let me know. Then we will close the demo.
Sir, same we can implement using loops also, right?
Sir?
Same we can implement using the loops.
Yes, we can use it. But the problem is we can't solve every problem by using loops. Only few problems we can solve. There are some limitations. Suppose if you take towers of Hanai, there are n number of things are there. You can't solve by using loops. If the input size is very small, then you can go for loops. If input size is keep on increasing, loops are not sufficient. In such cases, we have to use recursion. Okay.
Okay, sir. Thank you.
You will get clarity once if you see the programs. Okay. Any other queries, friends? Please confirm.
No, sir.
Yes, that's all about today's demo. So you can leave. The people who are having queries, you can ask me. Remaining people, you can leave. Yeah, thank you.